Hello, hi everyone. Good afternoon, all of you. Today we are going to three-dimensional space, second part. So, equation of a line in space. Equation of a line in space, 3D space. So this topic is very important. From this topic compulsory they have to ask 5 marks questions. So thorough all of you practice more times this chapter. Now before start this topic, what are the main things? It is related to vector algebra. I just explain the points. Remember these things. The first one, directed line. So directed line, let OAB be the directed line. What is the meaning of directed line? It has both magnitude and direction. So how to write AB vector? AB vector is equal to OB vector minus OA vector. So all of you keep in your mind, in vectors we studied these points. AB vector is equal to OB vector minus OA vector. So one of the result. Next thing, if two vectors are parallel, let us take A vector and B vector are parallel or collinear. The condition for parallel vectors, A bar is equal to lambda times B vector. So collinear, last class we proved. If drs of first vector is equal to drs of second vector, that means if two vectors are parallel or collinear, the condition will be A vector is equal to lambda times B vector. Keep in your mind, in vector we studied these things. Once again you revise the vectors also. And next thing, addition of two vectors. So let us take OAB. So OA vector, let OA vector is equal to A bar, OB vector is equal to B bar. So in addition of two vectors, direction must be follow. So OA vector, triangle of two vectors. So addition of two vectors, remember OA vector plus AB vector is equal to OB vector. Triangle of two vectors, OA vector plus AB vector is equal to OB vector. This is called triangle of two vectors. Next thing, you remember that products here I, J, K. These are normal unity vectors. So we studied in the first PUC all vectors. In vectors these all things will be there. Just I revise what are the required in 3D space we have to learn here. And here same vectors, I dot I is equal to J dot J is equal to K dot K is equal to 1. Remember all of you, I dot I is equal to J dot J is equal to K dot K is equal to 1. If you take the dot product with other vector, I dot J is equal to J dot K is equal to K dot I is equal to what? 0. We know all of you these results. What is I dot I? Is equal to 1. We should call, don't call into dot product this is. In vectors we should call dot product. I dot I is equal to 1, j dot j is equal to 1, k dot k is equal to 1, I dot j is equal to 0, j dot k is equal to 0, k dot I is equal to 0. So with different vectors given, answer will be 0. With same vectors given, answer is 1. So this is the concept of vectors only. Now we are going to three-dimensional space, equation of a plane in space. So this is what are the concepts in equation of a line in space. So how to determine equation of a line in space? To determine here, so we studied in three-dimensional geometry also. So two-dimensional geometry, we studied these points. Equation of a line in 2D. Do you remember that? What are those? The first one is point slope form. Okay, studied this one, point slope form. Second one is what? 2-point forms. 2-point form. What is the third one? Slope intercept form. Slope intercept form. What is the fourth one? Intercept form. Fifth one, normal form. So these all are different forms of straight line equations. We know all of you. Point slope form is y minus y1 is equal to m into x minus x1. 2-point form. Y minus y1 is equal to y2 minus y1 upon x2 minus x1 of x minus x1. Slope intercept form, we studied y is equal to mx plus c. Intercept form, x upon a plus y upon b plus z upon c, or x upon a plus y upon b is equal to 1 in two-dimensional. Normal form, x cos alpha plus y sin alpha is equal to p. We studied all these points, but these things how to relate it to in 3D space. Here in 2D, to find the equation of a plane, what are the necessary conditions? Which conditions are needed? Point and slope. In 3D, how to find equation of a line? Here we do not have slope in 3-dimensional. So what happens? Slope here in 3D, it becomes a direction. So to find the equation of a line, point required and also direction is required. Slope here becomes inclination. There is inclination. Inclination nothing but what? Angle only. Angle means here direction angle. So directions are required. Direction cosines or direction ratios. Slope nothing but here in 3D direction ratios or direction cosines. This is the first one. So the first possibility is find the equation of a plane, find the equation of a line passing through the point and parallel to vector. That is the first possibility. We have only two possibilities are there in 3-dimensional space. To find the equation of a line, how many possibilities are there? Two. The first possibility is equation of a line passing through the point and parallel to vector. Vector meaning what? It has a direction. Next here in this 2-point form. So here also 2-point form. That is equation of a line in space passing through 2 points. Next here convert third one, slope intercept form. Slope intercept nothing but what? Point slope form. So no need to find here. So here same concept. Intercept form in 2-dimensional we know the but in 3D we cannot, it is not defined, not applicable. In 3-dimensional intercept form not applicable. And next in 3D normal form also not applicable. So in this case how many possibilities are there? We have the two possibilities to find the equation of a line. What are the two possibilities? Equation of a line passing through the point and direction. Direction meaning what? Parallel to vector. Second possibility is what? Equation of a line passing through 2 points. Now we go through the concept of theorem. So what is the equation of a line in space? How to solve one by one theorem? Observe that. Today we have to talk only first theorem. This is very, very important. Nearly 10 to 12 times in exam given. 5 marks question. So what is the theorem statement? The theorem statement is derive the equation of a line in space passing through derive the equation of a line. I written shortly. Passing through the compulsory, what are the required here? Point, passing through the given point and parallel to given vector b bar in both vector and Cartesian form. Both vector and Cartesian form. So this is the very, very important. So thorough all of you. 5 marks question. So how to derive? Say they ask the question in exam also like this. Derive the equation of a line passing through the point and parallel to vector only in both vector form and Cartesian form. So to derive this one, what are the required, what are the given? So let us see derivation. I would have take 3D coordinate system. So this is the 3-dimensional geometry. Give the names x-axis, y-axis, z-axis. So with the common point O. If you are not understanding this one, let's go to the first video. I explained all these points. What are the coordinates of a point in space? X-axis, y-axis, z-axis, everything is explained in the first video. Next, what is the given first of all here? Line. So let us take line here. Take the any line. This is the line L whose direction ratios I consider just ABC. This is the line only. On a line L, so this line passing through what? One point is given. So given point, I would have take let A x1 y1 z1 is a point on the line. This is the given point. Now join OA vector. If I join OA, it has a direction. Why? Because this is the directed line. OA is a directed line. It has direction and magnitude. With the position, let OA is equal to A bar. That means let A bar be the position vector of a point A x1 y1 z. This is the given. So given value first of all write. So how to write here? What I have taken, what is the given, that only we are writing description part. I am writing here let A bar be the, this is the first sentence. Let A bar be the position vector of the point A x1 y1 z1 with respect to always we have to define with respect to origin in the Cartesian system. So this is the Cartesian system over. So this is the given. Next what he has given, parallel to vector. So this line is parallel to one vector. So which vector that is? B bar. So what are, this is a vector only. So vector form B bar is equal to, I take A1 or D are same here, A into I vector plus B into J vector plus C into K vector. Here no need also, okay, leave it. Why? Because these two are parallel. So line is parallel to vector only. So let us take, let B bar, what do you call that is? Given vector here. So let ABC, what do you call ABC? Those are called DRs of a lineal. Let DRs of a line otherwise we can write here, consider here or simply given vector is B bar, you know. So here parallel vector is, let B bar be a, B bar is parallel to, let B bar is equal to A I bar plus B J bar plus C K bar, or simply we can take, otherwise what do you consider, let A, B, C are the direction, let DRs of a line, simply DRs of a line L, DRs of a line L parallel to B bar or A, B, C. So you consider three numbers here, A, B, C. Next here in equation of satisfying this line, how many points are satisfying? So many points are satisfying. So instead of this one, take the one locus point. Let us take P, X, Y, Z. Be any point on the line L. So it is general point only, satisfying. So on a line, infinite number of points are there. So I consider one locus point. Now join OP. Join OP. OP line, join that here. So join OP line. So let R bar is equal to position vector of the point P. So now we consider, let R bar. So next given, that is consider, let R bar be the position vector. R bar be the position vector of the point P, X, Y, Z with respect to origin. So these are the taking values here. So given values are, first two are given. What is the first one? A bar be the position vector of the point A, X1, Y1, Z1. And what is the parallel vector here? Parallel to line L, that is B bar. B bar is equal to A, B, that is A I bar plus B J bar plus C K bar. This is the given data. Now we are going to here conditions, observe that. So this is, observe what all of you? O, A, P. What do you call this one from the diagram? Is it a triangle? Yes, OAP is a triangle. So using triangle law, using or simply from triangle OAP, from the triangle OAP, OA bar plus AP bar is equal to OP bar. Is it right? Yes, OA bar plus AP bar is equal to OP bar. It is called triangle of vector. What is the OA vector? A bar plus AP bar is equal to R bar. I take AP vector. AP vector is equal to R vector, taking this side. R vector minus A vector. We got AP vector. Okay, observing all of you. Next condition is what? Triangle of, from the triangle OAP we got AP vector. So OA vector we know that, OP vector we know that, AP vector right now finding. We found the value. Now observing these two what? AP vector and B vector, what happened? Aren't they parallel? If two vectors are parallel, what is the condition? A vector is equal to lambda times B vector. So first vector equal to lambda times second vector. So from this one, since AP vector parallel to B vector, AP vector is equal to what? Parallel to B vector. This means B vector is equal to, or AP vector is equal to lambda times B vector, where lambda is non-zero vector, non-zero scalar, where lambda is non-zero scalar. Remember all of you, it is a constant meaning. So this is the parallel condition. If two vectors are parallel, remember all of you, if two vectors are parallel, then A vector is equal to lambda times B vector. Collinear means here, lie on same line. This is the condition, parallel condition. Now we got AP vector is equal to R vector minus A vector is equal to lambda times B vector. This implies R vector is equal to A vector plus lambda times B vector. So which is called equation of a line. Equation of a line in vector form. In vector form. So what is the equation of a line in vector form? R bar is equal to A vector plus lambda times B vector. So keep in your mind, this is vector form. So we proved first one, vector form is over. Then next what we have to prove? That Cartesian form. How to show that Cartesian form? From this only, if you know the vector form, we can easily derive the Cartesian form. Cartesian form, nothing here. The second one is Cartesian form. So how to derive the Cartesian form? So take the point here. What is the A vector? x1, y1, z1. Write in vector form. Simply let A vector is equal to x1i plus y1j plus z1k. Already taken A bar with the position vector of the point A. So write in the vector form. What is the B vector? B vector is equal in vector form. B vector is equal to A into I cap plus B into j cap plus C into k cap. Okay, this is the parallel vector to the line L. Means both have same direction ratios. Two vectors are parallel, both have same directions A, B, C. and r vector, general vector, r vector is equal to x into I cap plus y into j cap plus z into k cap. These are in the vector form only. Now these values substitute in the first equation. Let us take this is as equation number 1. Substitute in equation number 1. Substitute in equation 1. Substitute here, r bar is equal to what? R bar is equal to what? X into I cap plus y into j cap plus z into k cap is equal to a vector. What is the a vector? x1 into I plus y1 into j plus z1 into k plus lambda times, what is the b vector? B vector is, what is the b vector? A into I cap plus b into j cap plus c into k cap. Substituted all values in the equation. Now simplify this one. How to simplify? This term taking on left side. Observe that all terms taking means what is the getting symbol? Minus. Okay na? From this x into I. So shall we take I common? X minus x1 into I cap plus y minus y1 into j cap plus z minus z1 into k cap. What is the rest of the term on right side? On right side, lambda times, open the bracket, lambda times a into I cap, lambda times b into j cap plus lambda times c into k cap. Hereafter, what to do? That is what? Comparing on both sides. Comparing on both sides. Comparing. So, what is the I coefficient? X minus x1. X minus x1 is equal to, here what is the coefficient? Lambda times a. From this, what is the lambda? X minus x1 divided by a is equal to lambda. We got x minus x1 by a is equal to lambda. Similarly, second term also comparison. That is y minus y1 is equal to lambda times b. Y minus y1 by b is equal to lambda. And third term, z minus z1 is equal to lambda times c. What is the lambda value? Z minus z1 by c is equal to lambda. From these three above equations, what do you say that? From the above equations, what do you say that? All values are equal to what? Lambda. So we write x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c will be equal to lambda, which is called equation of a line. Equation of a line in Cartesian form. Equation of a line in Cartesian form. Remember all of you, this is called equation of a line in the Cartesian form. So observe that all of you. What is the equation of a line in vector form? R bar is equal to a bar plus lambda times b bar. What is the equation of a line in Cartesian form? X minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. It is called equation of a line in Cartesian form. Okay, once again I repeat this one. Remember all of you, from the question, whenever you draw the diagram, the answer will be very easy. So let us see vector form. How to define vector form? Observe that from the statement, question given, point given, direction given. Direction means parallel vector. Take the line L, any line that is L in 3-dimensional geometry, and point let A is equal to x1, y1, z1. Any point that is on the line L with the position vector A bar. That is written in first sentence. Let A bar be the position vector of the point with respect to horizon in Cartesian form, in Cartesian system. Next, let ABC be the drs of a line L parallel to B vector. That is also given. But general point not given. We should consider generally. What is the point? Why? Because line satisfies number of points. So instead of all these, I consider locus point. Let P is equal to x, y, z is any point on the line L. Now we are observing. From that we got here, observe what? OAP, it is a triangle. So using triangle of vector addition. Triangle of vector addition, this is, remember all of you, triangle law vector addition. Keep in your mind, this is very useful. In first year also study triangle of vector addition. OA bar plus direction should be follow. OA bar plus AP vector is equal to OP vector. Substitute OA vector is equal to A vector. AP vector as it is. OP vector is equal to R vector. I need to find AP vector, R vector minus A vector. And one more condition what he has given, line and vector both are what? Parallel. Parallel meaning what? Lie on the almost all collinear. If two vectors are parallel, what is the condition? Both are differ by constant. So A vector is equal to lambda times B vector. That is AP vector is equal to lambda times B vector. So what is the AP vector? We got R bar minus A bar is equal to lambda times B bar, where lambda is a non-zero constant, it is a scalar. So R bar is equal to A bar plus lambda times B bar. It is called equation of a line in vector form. All of you remember, very very important theorem this is. What is the equation of a line in vector form? R bar is equal to A bar plus lambda times B bar. So remember, it is a point passing through the point and parallel to vector. So that statement important. And how to derive the Cartesian form? From this only we have to derive the Cartesian form. Take the all vectors in vector form. A bar is equal to x1i plus y1j plus z1k. B bar is equal to ai plus bj plus ck, and R bar is equal to xi plus yj plus zk. Substitute all values in equation 1. Okay, substitute in equation 1, that is x into y plus y into j plus z into k equal to x1i plus y1j plus z1k plus lambda times ai plus bj plus ck. Simplification. You know all of you, very simple simplification. Taking this term, open the bracket, arrange like this. I, j, k common, x minus x1, y minus y1, z minus z1. On right side, same term should be taken. Hereafter, comparing I, j, k coefficients. Here I coefficient is x minus x1. Here lambda times a. What is the lambda? X minus x1 by a. Similarly, y minus y1 is equal to lambda times b. Y minus y1 by b is equal to lambda. Similarly, z minus z1 by c equal lambda. From these above three equations, so this is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c is equal to lambda, which is called equation of a line in Cartesian form. If I take L, M, N or direction cosines, so what is the equation of a line? If L, M, N be the direction cosines of a line L, then equation of a line is x minus x1 upon L is equal to y minus y1 upon m is equal to z minus z1 upon n. This is called equation of a line passing through the point. Point, remember, x1, y1, z1, it is a point only. A, B, C are called direction ratios. L, M, N are called direction cosines. Keep in our mind, this is the very important topic. All of you practice 2 to 3 times on the paper and send me also. This is very important. Okay, clear this one? Do we have any doubt? Ask me here. This is the vector form, this is the Cartesian form. Okay, right.